7.5 is integration using partial fraction decomposition, or PFD. And it's not a calculus formula, it's another algebraic method for rewriting the integrand in a way that we can integrate. So when we look at this first integrand, we have an x squared minus 1 in our denominator. Even if I set that equal to u, my du would be 2x dx, and I don't have an x in my numerator. And as you know, we can't just multiply by x and then divide by x on the outside because we can't move variables around outside the integral. So what we want is a way to rewrite this integral so that we have two different fractions. Okay, and I'm picking two fractions because x squared minus 1 I know I can factor as x plus 1 times x minus 1. So my goal is going to be to use PFD to figure out what coefficients or what numerators go into those two fractions so that these two integrands are equivalent. So I'm going to do the algebra over here on the side, but this is the process that I'm going through to fill in these numerators. So right now I have 2 over x squared minus 1 is equal to, and I'm going to use variables here, so a over x plus 1 plus b over x minus 1. Okay, and I know that this x squared minus 1 is x plus 1, x minus 1. So what I'm going to do is multiply the entire equation by x squared minus 1, or both of those factors, so that I can get rid of all of these denominators. And so this is going to be gone here. Over here, x plus 1 will cancel. I'll have an x minus 1 left. Here, x minus 1 will cancel, and I'll have an x plus 1 left. So now, or you can think of it as getting common denominators and then just ignoring the denominators if you want. Also, same thing. So now I have an equation 2 equals, and then I'm distributing, ax minus 1 plus bx plus b. And I'm going to use this to write a system of equations to solve for a and b. I'm also going to consider this 2 as 0x plus 2, just so that I can think about what that x term is. Okay, so I'm using my coefficients of the x term first to write an equation. Since 0x is equal to ax plus bx, since those are the only x terms, I can ignore the x's and write this equation as 0 equals a plus b. And then looking at the constant term, oh, this should be an a, sorry. And then looking at the constant terms, I have a 2 and a negative a and a positive b. So I also have the equation 2 is equal to negative a plus b. Okay, at this point I have a system of two equations and two variables. I can solve this with elimination pretty quickly. Add the equations together, these already cancel out, so 2 is equal to 2b. Plug that back into either of the original equations and we get a is equal to negative 1. Oh, sorry. So I get b equals 1. Therefore a equals negative 1. Okay, so now putting negative 1 and 1 back into these numerators, okay, which are the same as these numerators, I end up with a negative 1 here and a positive 1 here. Make sure that you are putting the correct variable value with the correct denominator. In other words, I can't have a positive 1 and a negative 1 there. I can't interchange those, okay? All right, so now both of these are things that I can integrate pretty quickly using natural logs. If you want to write them as this is u and then du would be 1 dx, and then this would be u, and then same du, and put things in terms of u, you can, or this is a pretty straightforward one. So we get the negative 1 times the natural log of absolute value x plus 1 plus the natural log of absolute value x minus 1 plus c. Okay, and then I am going to use my log property to combine these two into a single log. Because this is negative, think of that as a negative 1 exponent, or think of that means we're going to be dividing on the inside of the log. So we get the natural log of absolute value x minus 1 over x plus 1 plus c. All right, and there's my answer.